I'm gonna build an AI that can play Minesweeper. But with a twist, I can only use C programming language and can't use any extra libraries, just like how the original Minesweeper on the Windows XP was built. But before I can make the AI, I first had to rebuild the full game myself. I started by opening the old Windows XP Minesweeper, playing a few rounds, and paying close attention to how it looked and felt. For the graphics, I decided to stick with the Windows.h header file. This is part of the Windows API and allows you to make real Windows programs with full access to system features. With it, you can draw windows, handle mouse clicks, paint things on the screen, and more. Making a GUI in C is not like doing it in the modern languages like Python, where you can make a window with just a few lines. In C, it's much harder and more manual. You start by including Windows.h at the top of your code, then you create a window class using something like WND class EX. It's a struct that stores things like the Windows style, the icon, and a pointer to your message handling function, called the window procedure. Next, you register the window class with register class EX. If that works, you use create window EX to actually create the window. Once the window's up, you enter a message loop with get message, translate message, and dispatch message to process events like clicks and resizes. Inside the message handler function, different events have different codes. For example, this is used for drawing things. This one is used when the left mouse button is clicked, and this one is when the right mouse button is clicked, and things like this. For drawing, you can use GDI functions from Windows.h, like createDC, to get a device context, and then functions like rectangle or text out to draw shapes and text on the screen. One of the major challenges was drawing the digital counters at the top of the game. At first, I thought these numbers were drawn by connecting lines and points with code. The Windows API allows you to define points and connect them, so I tried to recreate the digits that way, but no matter how much I tweaked my code, the result didn't look like the original Minesweeper. Eventually, I found out that the original game doesn't draw these numbers with code at all. It uses bitmap images. The numbers, the smiley face button, and the other UI parts are just pre-made images stored as resources. They're simply drawn onto the screen when needed. And I don't know what I was thinking trying to use points in code. Once I switched to using bitmap like the original, everything looked perfect. I wanted my remake to look exactly like the old Minesweeper, and thankfully, it turned out spot on. But since I was rebuilding it, I threw in some extras that the original doesn't have, just to make the experience smoother and more fun. For example, in the old Minesweeper, you could court, a trick where you click on a number that already has the right amount of flag around it, and all unmarked neighbors open instantly. The original used the middle mouse button for this, but I changed it to the left mouse button, because who uses middle mouse button to do things? Another improvement, the old Minesweeper board looked tiny on modern screens. I added a zoom option in the menu bar, so you no longer have to squint to see the cells. One of the most important limitations of the classic version is the board size. Original Minesweeper stops you at 24 rows by 30 columns, but I made it so you can go up to 999 by 999. This took careful memory management and optimization so the game wouldn't slow down or crash, but now it can handle huge boards. Another feature I added is a tutorial mode to help beginners learn the rules. In addition, I created a completely new feature called Neighbor Highlights. When the mouse hovers over a cell, all neighboring cells glow, making it easier to avoid misclicks on large boards. It doesn't seem too much, but trust me, it helps a lot. Now it's AI time. My AI is based on something called Constraint Satisfaction Problems, or CSP for short. This type of algorithm sees the puzzle as a bunch of variables and rules, and it tries to find answers that fit all the rules. In Minesweeper, every revealed number cell is a constraint. For example, out of these 8 neighbors, exactly n are mines. Each click reveals a new constraint, and the AI solves them step by step. First, it starts with a simple and fast approach. It uses local logic. For each revealed number, it counts the flagged cells around it. If all the mines are already flagged, then the rest are safe. If all the hidden cells left equals the number of mines needed, then they're all mines. When simple local logic stops giving new results, the AI moves to advanced logic. Here, it compares constraints with each other. If one constraint is a subset of another, it can deduce safe cells. For example, if 5 cells cells have exactly 2 mines, and inside that group, there is a smaller group of 3 cells, also with exactly 2 mines, then the remaining 2 cells in the bigger group must be safe. To boost accuracy, the AI also looks for specific patterns, like the famous 1-2-1 arrangement. It detects the configurations automatically and solves them just like any other logical clue. But Minesweeper isn't always solvable by logic alone. Sometimes you have to guess. When that happens, the AI switches to probability mode. It calculates the chance of each cell having a mine. If a cell isn't part of any constraint, it uses a global probability based on total mines left and hidden cells left. The AI chooses the cell with the lowest risk. It also gives a small advantage to corner and edge cells, since in real play, they tend to be safer. I tested the AI on a very challenging setup, a board of 95 by 44 cells with a mine density of 10%. This setup balances logic and guessing, since more than 10% is more based on guessing and less than that is so easy to solve. I ran 100 games and this was the results. Considering that some positions are mathematically impossible to win, this was a really good result. If you enjoyed this video, please subscribe. Thanks for watching.